The type of flashback arrestors you see people dealing with their HHO cells are more like the flashback arrestors that they use on oxygen lines. And I believe these devices are they are 3 separate angles of attack to stop a flashback all in one. You've got your anti-reverse flow valve, you've got some sort of either a screen or a sintered bronze kind of sponge looking thing, as well as a temperature release valve. And so the bronze sponge will prevent a flame from traveling back through there. The anti-reverse flow valve will prevent a mixing condition to exist upstream of the arrestor, to prevent flashback favorable conditions in the hose. And then the thermal thing is to prevent what I call a burn back. I think it's still a flashback, but where a flame is slowly burning back down inside an oxygen hose, because the hose itself is burning because of it's in the presence of pure oxygen, so damn near anything burns in pure oxygen. And the hose itself is burning and the flame's traveling back. It'll heat up this spring-loaded valve, which then will shut off the flow of oxygen and stopping that problem. But in these applications, the camping stoves, even this blowtorch, the way it came, there isn't anything like that. There is a sintered bronze filter, and perhaps it doubles as a flashback arrestor, but there's one of those little bronze sponges inside here. And so if that's what's necessary to prevent the danger of a flashback here, then well, I do have one. It's in here. I guess what I'm trying to say is I'm not really worried about it, and also in a way it's a very difficult thing for me to experiment with, judging the effectiveness of any flashback arrestor I build, because I can't make one happen. I can't make a flashback happen, so I don't know how to stop something I can't make happen anyway. And I don't believe that any flashback happening in here could get past that tiny freaking hole. And I'm going to cover that now, that hole. Alright, let's talk about orifices. Way back when I started this project, I looking at this thing, wondering about how I could cannibalize it for parts or whatever, and upon taking it apart, you can see on the blowtorch you got your primary combustion air, and then in the end, hold on, in the end there is a way to create turbulence in the gas stream, and that anchors the flame in here. If I were to remove that little star-shaped brass thingy, this would not work at all. And here is the orifice for the blowtorch. If I can turn and get better light. You see it? No? Me neither. It's so freaking small. I can't see it. The only way to see it is to remove the orifice and hold it up to the light. Then you can see it. But if you didn't know there was a hole in that thing, it would look just like a plug. Just a regular plug. Which now presents a sort of a technical issue. This torch doesn't generate a lot of flow, obviously, and when thinking about modifying this thing, I'm like, well, I need a larger orifice. And there's really no way to go from the tiny hole that that thing has to a slightly bigger one. This, what is this, a 1/16 inch drill bit? This is as small as drill bits typically come in your hardware store variety drill bits. And so you could see if I were to try to drill that out with this thing, basically what I'm saying is if I'm going to make the hole bigger, I have to make it way bigger. And so that's when I abandoned the idea of using this as my stove. I began experimenting with these 1/8 inch plugs. And you can see still how small that hole is compared to this drill bit. And the way I drilled that is with these mini drill 0.016, and here is that 1/16 inch drill bit for comparison. These are very small drill bits capable of drilling very small holes. In order to use this type of drill bit, you clamp it into a pin vise. Clamp that tiny drill bit in there, and I drilled the hole with a very steady hand. Took about half an hour, I think, to drill that tiny hole. So yeah, they do make drill bits that are a little bit smaller than this, but I can't imagine trying to drill through a brass plug with something so fragile. This is really pushing the limit of what I can do. So I've got my nice tiny hole in this plug, and I determined that your entire stove, I've referred to this as the heart of the stove before, your entire stove is based on the hole that you can create here. If all of the aspects of the stove happen to be in balance one another, this one is the one that is the hardest to change. I can't go any smaller than that. Therefore, I can't go any smaller than that. If I tried to shrink any of that down, it would require a smaller orifice, and I can't make one. And so, with the method that this thing is built, this is as small as it gets. With a 0.016 diameter orifice hole. That pretty much covers everything that makes it burn. Actually, maybe I'll do... Yeah, that's pretty much it. Pot stand. Just started as a washer, which I made these sort of diagonal cuts. I made this cut here, which left me with a little flap sticking out like this, and I bent that 90 degrees, drilled a hole, which gave me a spot to mount my pot stand arms, legs, whatever, arms. They stick up, not down. Pot stand arms are made from, they call it a cookie flipper, although I don't know why you'd want to flip a cookie. Usually, you cook them and they're done. But It's a cookie turner, cookie flipper, whatever, from the dollar store. I cut four pieces. I only used 3. I got a spare now. 4 pieces, and then these 2 holes are what I used to sandwich all 4 pieces together. And then after that point, with all my filing and cutting, that way all of my pieces would be exactly the same because they're all sandwiched together. It's common practice in like woodworking with plywood. You'll sandwich all your plywood pieces together and shape them all at once and then separate them later. The legs are just, I don't recall the exact diameter of this, but this is stainless steel rod, and in the top I've notched it out, all 3 of them. A handy trick I found for this one I just eyeballed, but if you want to divide something like this, divide a circle into perfect thirds, is to use something like this. This is a 6-point thing, and so if you set this down on there, I'll line them up, every other point on the hex is a third, and you see that one's a little off. And so if I wanted it to be perfect, next time I'll put this thing down on there, and every other point mark it, and I'll have it divided up into thirds perfectly. Perfectly as you can get it anyway. This, another stainless steel washer, got 3 holes, and then I've cut them in at an angle. So that when I probably, let's see if that thing will help me do this one-handed. Am I doing that right? Yeah. So in the when the legs come through the washer, now I got that little thing sticking out, and I'm going to assemble the rest of them and show you how that goes. So the snap ring now sits down in the notches of the legs. That will allow them to pivot under spring tension somewhat. You can see even I can hold the snap ring, and that groove retains the legs. They can't, well, you can't pull them out. They won't fall out now that that spring is engaged that knot. In between the pot stand and the legs, I had to fill with something, some sort of spacer. This is just a piece of aluminum. I cut this off an old bicycle handlebar. Just whatever you had lying around. So it worked out nicely. So I'm gonna put this thing back together. There it is with the quick disconnect. Very quickly I'll cover the whole point of that snap ring thing. The light isn't very good here. But now they can pivot, and all the legs can fold in like that. Not the most compact thing, but you know.